Now, before we dive into code, there's one concept I want to explain to you before we get started. And that concept is the database context or DB context. It's often called the DB context because that is the name of the base class that Entity Framework offers when you're implementing your own. Now, the DB context is really the MVP in the entire Entity Framework system because it ties all of the things we want to do together. As you remember, what an ORM does is mapping between rows in the tables in a database and objects in memory to be used by our code. And the first thing a DB context does is open a connection towards the database engine, because opening database connections is actually a very costly affair. It requires a three-way handshake, which actually takes quite a bit of resources, both on the server and on the code side. Now, our DB context does this for us, and it keeps the connection open for as long as it needs to. Now then it offers to our code an API that is very consistent, that is strongly typed, and that definitely is agnostic to the underlying database engine. So when you write C# against a DB context, you don't have to know which database engine it is using. And that's very powerful as well. So when I call one of the APIs on the DB context to query data in the database, what will happen is a select will be executed on the database side, and it will be returned and materialized as objects, not as rows. If those objects then change, if we add new ones or we update existing ones, we remove some, then actually we can persist all of those changes through the DB context, and that will be executed on the database side as insert, update, and delete statements. And the DB context will manage all of that for us. So it's really the little thing that ties the objects in the code side and the tables in the database side together. Now, what information does the database context need to perform its duties? Well, it needs to know about three things. It needs to look at your code and to know what shape the classes have, because that is the type of objects that are going to have to come back from the DB context whenever we do something. It will also need to figure out what the tables in the database look like, because that is what it's going to execute all its queries against. And then it needs to build a map between those two things, because that map will actually define what change on the class side will have to be propagated to the tables in the database. Now, luckily, we don't have to provide all of that mapping and all of that table information every time, because Entity Framework works by convention by default. So for instance, it will take the name of the database set and assume that that is the name of the table. If you have a property called ID or the class name plus ID, then Entity Framework will assume that that is the primary key, and so on and so on. So a lot of it can be derived by convention. It's only when you start doing things that are different from the conventions that you have to supply Entity Framework extra information. And it will get that information in the startup of its first DB context. Now, that first DB context is the one that is going to build this entire mental model. So when you start a new process and you hit the first DB context of a certain type, Entity Framework will first look at all the conventions and then all of the extra information that we supply it to build the model about these three things. And that can take a couple of 100 milliseconds. That's why a lot of developers have the feeling that Entity Framework is slow, because by nature, what we do the whole time is we code something, we fire it up, we hit that first DB context, the whole mapping thing happens, and then we get the first results returned. But in reality, all these subsequent DB contexts and all these subsequent queries are actually really, really fast. So we as developers get the wrong impression about how fast Entity Framework can be. Now that is how the DB context works behind the scenes, and now you know why you will see certain behaviors. You've now learned what an ORM is and how it maps between the objects in your application and the rows in the tables in your database. We've also discussed what EF Core is and where it sits in the ORM landscape in the .NET ecosystem. We've then taken a closer look at the responsibilities of a DB context and which mental model a DB context uses to perform its duties. And that should give you enough of a context when we start writing code, and that is exactly what we will do in the next chapter. There, we're going to build our first application with EF Core. Before we start coding, let's get our system set up for the rest of this course. I'm going to show you how to configure your system so that you can follow along with all of the code samples that I'll be showing in the next few chapters. Now, for starters, I provided a starter solution. It's a very simple ASP.NET application, and if you're not familiar with all of the details of ASP.NET, that is not going to be a problem. I'll only be using the simplest features, and whatever I use, I'm going to prepare for you. So this course is going to be about Entity Framework and not about ASP.NET. But if you want to learn more, go read a few blog posts, or maybe watch Nick's course over here on DomeTrain if you want to learn all the little details on ASP.NET. Now, this solution doesn't do a whole lot. All I provided is a simple controller with read and write actions. So this is a web API controller, and I provided a model class for the data. And if we execute this, we see the Swagger UI for this API. And we'll be implementing all of the data access for this API using Entity Framework. So that's what this course is going to be all about. Now, this works on one side. On the other side, we need a database as well. And I chose to run SQL Server in a Docker container. So if you go over on Docker Hub and you search for the SQL Server images, you will find this page. And there is a command right here that you can copy paste into your terminal of choice to get a running instance of SQL Server. So if I do just that, I could execute it as is and I'll get a running SQL Server. I'm just going to modify a little thing or two. So the first thing you see here is that there is a SA password. The SA user in SQL Server is your system administrator, and you can provide a password for it on the command line when you start the container. So I'm just going to say my SA password 123. Mind you, this needs to pass SQL Server password policy requirements, so this one will work just fine. That is from now on my password. The second thing you're going to want to do probably is to add a restart behavior for this container, because if you start it up like this, it's just going to spin up the container, but when you reboot Windows, your container will not automatically be restarted. So if you want to fix that, you add the restart parameter, and the one that you're probably going to want to use is this one, unless stopped. Unless you manually stop the container, it will always restart with Windows, and that is the behavior that you want. Now, if you know nothing about Docker, just know that if you run this command, what it's going to do is it's going to pull in the container from Docker Hub and it will run it on your system. And while it's downloading, I'm going to explain you why I made the choices that I made. First of all, I'll be using SQL Server for most of this course. Not because Entity Framework works best with SQL Server, it works perfectly fine with Postgres or MariaDB or other database engines as well. But because the majority of the .NET market is still targeting a Windows stack or an Azure stack, that's why I opted to use SQL Server for this course. Now, the second reason, why do I choose to run this in Docker? Well, the reason for that is I don't know which operating system you're using, and this Docker container will actually work just fine on macOS or Linux. So if you're running on one of those two platforms, you can actually use this Docker image on those to follow along the rest of this course. For my IDE, I'll be using Rider, but you can use whatever you want. You can use Visual Studio or Visual Studio Code as long as you can run your .NET code. Now, once this command has completed, as you can see here, I'm using Docker Desktop and I can see here that my SQL Server instance is running on port 1433, and that port is forwarded on my local host. 1433 is the default SQL Server port, which means that from now on, if I want to use a tool like Azure Data Studio, I can actually connect to this database and take a look. Now, if I add this server here, all I'll have to do is enter localhost because the port is mirrored, and I'll be using a SQL login, of course, the SA user, which we have configured the password for. Now, that SA user will allow me to actually browse my database list, but something else is going to happen first. It's going to ask us to trust a certificate. It's because that Docker container spins up with a self-generated certificate, which is totally fine for development purposes, but in production, you're going to have to add your own certificates. Now, we're just going to trust it because we are using it for development purposes only, which is exactly what it is meant for. Now that I have trusted the certificate, I should be able to expand a list of databases, and we can connect to the master database if we want. I'll have the drop down here to trust the server certificate, and we can connect to this database. Now what you'll be seeing is a working database, but we don't want to add our tables to the master database because the master database is a system database. So on this SQL server, we're still going to create our own database. We can do that by just opening a new query on this SQL server and just type create database, and we will use a database called moviesdb. Now, if we just execute this command, we now have a working database. As you can see here, if you expand the databases node or refresh it, you can actually see your database here, and that is the database that we will be working on with this course. So we now have running code and we have a database, and we will use Entity Framework to build everything in between.